Okay, so our focus today is writing the overall balanced redox equations. And so we'll use the examples that you've got in your topic booklet there. Let me just bring mine up because I can't seem to find my copy. Just stick it on here. Near the back, isn't it? Ooh, there we go. Let's start with number 3, adding magnesium to sulfuric acid. Okay, so of course you know the overall balanced symbol equation for magnesium sulfuric acid, but let's imagine you didn't. Then one approach is to tackle the magnesium and the sulfuric acid separately. So the magnesium is reacting to produce something and the sulfuric acid is reacting to produce something, and one of them must be oxidation and one of them must be reduction. So let's write two half equations for the magnesium reacting and the sulfuric acid reacting. Let's just make it a little bit easier actually, because the sulfate and the sulfuric acid is a spectator ion. Let's strip it right back to its key ions. So we've got magnesium reacting with acid, and acid is just H+. So can you write me a balanced half equation for what happens to the magnesium, what happens to the H+ ions, and which is oxidation and which is reduction? Right, so the magnesium is reacting to form magnesium 2+ ions, and in doing so it must have lost 2 electrons. Okay, if it's lost electrons, it's been oxidized. Oil rig. H+ has formed that was a squeaky pot. Yes, it's formed hydrogen gas. How has it done that?
By losing 2 electrons.
Yeah, we need 2 H+, and of course it will have gained 2 electrons because it's being reduced. Okay. Years of practice. So put two half equations together. All we need to do first is balance the electrons, which in this case is already done for us. 2 electrons balances 2 electrons. So now all I need to do is add everything on the left to everything on the left. So we've got the magnesium and the 2H+, and everything on the right to everything on the right. So the Mg2+ and the H2. And we can ignore the electrons because we've specifically set it up so they cancel. So that's actually the best version of the overall equation for that reaction, because the sulfate doesn't really do anything. We call it a spectator ion. Sulfate's not really part of the game here. Just you can't get acid on its own. It has to be something acid. Okay, right, so that was a fairly straightforward example. Next we had iron sulfate, potassium permanganate. Okay. So our next one, we started off with iron 2+ and what used to be called potassium permanganate, now it's called potassium manganate 7. Does anyone know what the iron 2+ is oxidized to? There's kind of a ceiling on how many electrons iron can lose. It can only get as high as 3+. Yeah, so definitely being oxidized there. And You might remember what MnO4 minus is reduced to. It was in the, well, there's a couple of options actually. It's not magnesium, no. What's the charge on the manganese anyway? We're on 2+. Okay. All right, so our next step then is to balance those two half equations, then balance them with each other and add them together. Okay, let's do this then. Tom, what do I need to do to this top equation?
Add E minus on the right hand side.
Losing an electron, so it's being oxidized, that's right. Permanganate now,
And the oxidation state of Mn.
which is
+7.
+7.
Yeah, add not 2. Add 5 and minus.
So we've got 5 electrons on the left.
Balance oxygen to do +4 H2O.
Balance the oxygen with water.
And do balance the hydrogen to +8 H+.
Balance the hydrogen with H+. Check the charges. Let's just get rid of that. Check the charges. +8, -5 is +3, -1 is +2, which checks out with +2. Before we can add left to left and right to right, Ryan, what do we need to do?
Balance electrons.
And how do I go about doing that?
On the top equation, put a 5 in front of each.
Okay, so if I have 5 lots of everything on the top, then the electrons will cancel. So on the left here I've got 5 Fe2+, 8 H+, and the MnO4 minus. And on the right I've got 5 Fe3+, Mn2+, and 4 H2O. It's a good idea just to check your charges again. 5 lots of +2 is +10, +8 for 8H+, -1 all adds up to 17. 5 lots of 3+ is +15, +2 adds up to +17. Okay. So if the charges check out both sides, you're probably right. Might not be right, but if the charges don't check out, it's definitely wrong. Okay, last one. Let's do the last one. So we have, by the way, 4 and 5 both have acid in. Remember, the acid is what allows us to add H plus to the equation. If you don't have acid there, you can't add H plus, but all the equations you're going to see, certainly in year 12, are going to have H plus around. Anyway, sodium sulfate 4. So sodium sulfate 4 is sulfur with an oxidation state of +4, which is SO3. Remember that 8, wherever you have 8 attached to anything, carbonate, nitrate, sulfate, it means there's oxygen present. And then the number at the end, the sulfate 4, tells you the oxidation state of the sulfur. So sulfate 4 is being oxidized, and it's oxidized to sulfate 6, SO4, 2 minus. And then potassium dichromate, we've seen that one before, is being reduced to, does anyone remember? CR3 plus, thank you dear. Okay, that's all you need. Balance the two half equations separately and then put them together. Right, let's run through it and we'll see. Some stuff might just come out in the wash. Lucas, could you start off by balancing SO3 to SO4, please?
So you need 2 E minus on the right.
Yeah, so it's going from +4 to +6, so losing a couple of electrons, being oxidised.
And then balance the oxygen, so H2O on the left.
H2O on the left to balance the oxygens,
And then 2H plus on the right to
2H.
balance the hydrogens.
plus on the right, and then that checks out. The charges add up to -2 on both sides. Thank you. Neo, could you do dichromate for us? Thanks.
Yeah, need 6 electrons in the left.
Yeah, so it's +6 down to +3, but there's 2 of them. Don't forget the 2 in front of CR3 plus.
And then need 7 H2O on the right.
7 H2O on the right.
And then 14 H2O on the right.
Okay. Marvellous. Louis,
I did it. I was just celebrating.
what do we have to do before we can put these two monsters together?
You have to match the electrons.
Okay, do that for us, thanks.
So you times the oxidation one by 3. So you just put 3 in front of them.
3, 3, 3. That'll become 6 electrons. That'll become 6H plus.
And then when you put them together, the electrons cancel out.
They will.
So it'd be 14H plus.
Something else will cancel out as well. Let's leave it for a minute. But while I write this up, perhaps you can tell me what it is, or think about what it is. Great equation.
This water H2O's on both sides.
Okay.
You cross off the 3H2O on the left,
Cross off the H2O on the left.
and then take 3 off of the one on the right.
So that will go down to a 4.
There's also H pluses.
Yeah.
on both sides. So you take the 6H plus off the right, and leave 8 on the left.
Okay, let's check those charges. 8H pluses is +8. 3 sulfates is -6, and -2 makes a big old 0. 3 lots of -2 is -6. 2 lots of +3 is +6. Phew. It's a relief when they check out. Okay. Okay. I've lost my topic booklet again. Oh yeah, on the exercise, exercise 2, question 2, just has 3 pairs of half equations. The half equations are already balanced. You just need to balance them with each other and stick them together. Can you do that now? Write the overall balanced equation, cancel anything that needs cancelling. Once we'll have a look at question 2, we'll have a look at question 3, which is much harder because it doesn't give you the half equations. You have to work those out yourself, and it only gives you some clues. So have a go at question 2 and then go on to question 3 on page 18 and see how you go.